Alright, is your head still spinning from chapter 10.1? Because I know mine probably would be. Now, chapter 10.2. The first part is probably going to be the worst one, but it's going to get easier when we get to scientific notation. Now, negative exponent rule. If we have 5 divided by 25, well, 5 goes into 5 one time, and 5 goes into 25 5 times. And so that gives us 1 over 5. Well, let's go back to the exponent rules. 5 is just 5 to the first power. 25 is 5 squared. So, using our quotient rule, this gives us 5 to the 1 minus 2, which gives us 5 to the negative 1. Ew. Well, if I started with the same things, I had better end with the same thing. So, I put a 1 down here, and what I do is I move this across the fraction bar, and that becomes positive 1/5. So symbolically, what that looks like is a to the negative m becomes 1 over a to the positive m. Alright? Now, my rule. Move the thing that has a negative exponent. Just because there's a negative doesn't mean you do anything to it. But move the thing that has the negative exponent across the fraction bar and make the exponent positive. So when I have 6 to the negative 2, that becomes 1 over 6 to the positive 2. And we know that this is 6 times 6, so that gives us 1 over 36. Now, like I said here, it has to be an exponent. My exponent here is a positive 1. That means this must stay where it is. However, this has a negative exponent, which means it has to come up front, or come up to the top. So negative 1 times p to the positive 4, which gives us negative p to the 4th power. If you've got questions, please do not hesitate to ask them. Now, I'm going to show you the shortcut because there is a long way to do this, and it's ugly. So, let's look at this shortcut. I just bring this across the fraction bar, and I move this one across the fraction bar because both of them have negative exponents. So that becomes y to the positive 7 over x to the positive 5. And that's it. So if you use my little rule here, it really simplifies things. Oh, what about this? It's negative inside, but it's also negative on the outside. So when it's negative on the outside and there's a fraction inside, just do this. Flip it over and make the exponent positive. Now, dividing by 1 can go away. So that gives us negative 4 times negative 4, which gives us a positive 16. Yuck. Now, positive 4 goes into negative 12, negative 3 times. This has a negative exponent. It moves up. This has a negative exponent. It moves up. Negative exponent, it moves down. And remember, same thing divided by same thing, chop chop goes away. So, let's rewrite it. Negative 3, our m to the 5th power stayed where it was. Our x has to come down. So now let's go to the bottom. m to the second is negative, so it has to come up. So m to the second, and x to the third. Now, this x to the 7 goes down. M times an m, we add our exponents. But an x divided by an x, we have to subtract the exponents. So, x is bigger on the bottom, so it's going to stay on the bottom. So negative 3m over x. 5 plus 2 is 7. But 7 minus 3 is 4. And is it that easy? Yes, if you let it be, it will be that easy. Now, is f easy? Not really. First thing you have to do, x to the 5th, x to the 5th, chop chop. Z divided by z, chop chop. Y by itself has an exponent of 1. Now let's deal with the numbers. 3 goes into 3 once, and into 6 twice. Now, I'm going to treat this a little different because it has a negative on the outside and a negative on the inside. So I'm actually going to distribute this. And remember, 1 times anything, the 1 goes away, or it hides, kind of. So y to the negative 7 times negative 3 gives us y to the 21. I had a brain fart for a second. And then 2 to the 1 to the third, negative 3 power is 2 to the negative 3. And then y to the negative 3. Well, guess what? Both of these have negative exponents, so it's going to come up. So 2 to the third power, y to the 21, y to the third. Hey, everything in the denominator just went away. Now 2 to the third power is 8, and y to the 21 times y to the third is y to the 24. Now, is that an ugly piece of mess or what? Yeah, it is. But know this, you are going to have a problem that looks like this. So you better take really close attention on this and take some really good notes. Now, scientific notation. When you see 3 lines like this, it's a definition. Is a convenient shorthand of writing really big and really small numbers. Here are your steps. 1. The decimal goes after the very first, only the very first counting number. And counting numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. Not 10, 18, 19, 29, only 1 through 9. Then, write all other significant digits. So, this step next is add to that times 10 to an exponent. If the original number is bigger than or equal to 1, the exponent is positive. If the original number is smaller than 1, your exponent is negative. Then your exponent is the same number of times you move your exponent, the decimal. Sorry about that. Decimal had to be moved. So, when you see this, okay, it's hundreds, thousands, millions. 5,906,000,000 kilometers is the distance from the sun to Pluto. Now, do you want to try to make a mistake on typing all those zeros into your calculator? Probably not. So 5 is our very first counting number. Then we put a decimal and we write 906. Okay, that's step 1. Let's go to this one. This is the size or the mass of a proton. Now, I don't know about you, but I would seriously not want to try to type all those zeros in. So 0, 0, 0, 0, 1. That's a counting number, so 1.65. Now, step next. Add to that times 10. So times 10 times 10. This just means you've got an exponent. Okay? Now, our original number, here it's positive. So I'm going to have it's bigger than 1, so I'm going to have a positive exponent. This is seriously smaller than 1, so I'm going to have a negative exponent. Now, if I don't see a decimal, it comes at the very end to the right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. To get the decimal from here to in front of the 5, I had to move it 9 times. And with number next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So my exponent here is a 24 because it took 24 times to move it from here to in front of the 1. Now, changing back to standard notation. That's what the original number is. Alright, so when I have 5.09 or 5.9012 times 10 to the 7, just remember this. When you're taking it back to standard, you move it in the same direction as the number line direction. So a positive goes to the right. 1, 2, 3, 4, 5, 6, 7. So you fill 3 zeros in there. So 5, 9, 0, 1, 2, 0, 0, 0. And do you have to put the commas in there? No, I just tend to like to. Now, 9.0210 times 10 to the negative 3. The negative number line direction goes to the left. So 1, 2, 3. So 0.009021. Do you have to put this 0? No, because it's not a significant number.